this presentation that I'll be giving you is about real life, let's say, experience, implementing, designing, most importantly, or more important, designing the NSX and implementing that solution in real life with customers here within the country. We also do the consulting outside of the country. So yeah, I mean, there's the introductory part. So just to tell a couple of things about myself. So I work for a company called NIL. I've been there for, what, 17, 18 years or something like that. So maybe too long, but still. I started as a networking engineer. So my background is networking. That's why I have the CCIE and all that comes along, security. But for the last, let's say, 8, 9 years, I've been focusing on the data center technologies, which is not only the networking, not only virtualization and compute, but also storage. So all, let's say, 9 yards. And most importantly, because these days you really cannot go without automating things, because that will give you the best results. Even you'll see during the presentation, I will tell you, even with the NSX, it has a lot of built-in automation, but you still would like or would need to do an extra mile to automate things, because that will ease your life when you do migrations, when you do deployments, and most importantly, because you have the APIs. If you deploy the cloud, public, hybrid, whatever you call that, whatever that is, private, you need the automation, because you standardize, you do the templates, and then you do automate to really implement things. You can find me at this email address, mrobas@nil.com. You can find me at Facebook, LinkedIn. This is usually, I'm an engineer by myself. I do many different things at NIL. I do the pre-sales, I do the designs, implementations, also support for some of the customers, because I want to keep my feet wet, so I like to fiddle with the technology. That's why this is how I usually test the technology. I don't just believe the data sheets, I don't believe the configuration guides. At NIL, we really want to test things, so, you know, drive things to the edge to see how they respond and all that. And along, because you have to do and implement things, you also collect some of the, let's say, certifications, also the VMware certifications for the NSX virtualization and so on. So first, a disclaimer from my side. So let's say I don't want to feed you with marketing stuff. I will give you the real-life experience, which is positive. But of course, when you do implement things, you know, every technology has some, maybe let's call it roadblocks or whatever, but that's why we are the engineers, right? That's why we have the job. The most important thing with any kind of technology, also with the NSX, is that don't go around seeking for the problems that would fit that. The technology by itself doesn't solve the problems. It's not that technology, just by deploying something, you will solve the problems. You really need to think about the problem, the challenges, the issues, see, analyze, do the design, and then apply the technology, because technology, like NSX, it's built with a certain purpose. It's a tool. You have to know how it works. You have to know where and how you can use it and apply it, and it will give you the best results. You know, the approach where let's just throw something, deploy, start clicking, doesn't give you the best results. So as I'll tell you a couple of times, the design, the homework is really, really important also in this sense. So NSX is basically SDN NFV solution, because you can deploy virtual routers, firewalls. You have a distributed firewall, as you've heard. You can deploy the security policies, the load balancers, so many, many, many things. It's also the SDN solution, because even though the SDN is a marketing term, basically it has controllers that are central point of reachability information. So they have the ARP tables, MAC addresses, VTAPs, so all the information necessary to forward the traffic from one endpoint to the other endpoint. Let's say a VM to a VM. You could also have a physical workload which you can integrate in a certain way with the NSX. So there are ways how you can do things. Enough with the disclaimer. How it usually begins with any project usually. You know, you have a new shiny technology, somebody starts telling you about that, or you read these days, we Google everything, or we are being fed with, I don't know, even through Facebook, and you start thinking, oh, that might be a good idea. We did it the same, and it's always typically like that. Those that are more bold, they go and try stuff before the others. You've probably heard about the curve. So there are the early adopters. Those are the most bold customers, let's say, or those that really try stuff. They're on the edge. They face the bugs and everything. And then there are all others that do things. And then at the end, those laggers which try stuff where everything is really, really more or less already, let's say, business as usual. But basically, the way how it usually begins is this. You have certain islands in your data center, in your environment. It doesn't have to be a single one. There can be two. But there will be islands. Islands of compute, storage. Multiple islands of compute. Multiple islands of storage. Multiple islands maybe even of the network. In bigger environments, you have different teams managing that, unless you're suffering from schizophrenia and you're one person for all these, let's say, roles, in a good sense of schizophrenia, not a bad sense. And you need to, or they need to manage all that. So it's slow adapting to changes. So whatever you need to do, it takes ages, not days, weeks, or even months to, I don't know, deploy a new segment and applications and all that. So that's typical challenge of classical environment. That's why, let's say, a cloud term was conveyed a couple of years ago, and everybody talks about cloud. Usually when you start with the NSX, the best way to do it is an evolution-based approach, because NSX in a whole solution in the data center, if you call it software-defined or whatever, it's part of the whole solution. So it will solve you definitely certain problems, but if you're not really taking into account some other aspects, you might not get the best results, and the end result to you might be that, oh, that sucks, but it's not true. Again, as I've said, you need to apply the technology in a proper way to solve the challenges or issues, problems, whatever you call them, so that you really are using it for what it was built and meant for. So usually it's conducted in a phases. So it's going to be the NSX is the SDN NFV solution. You'll probably have to do something to your physical network, as we'll see later. And yeah, well, you know, if you really want to be very flexible, deploy environment like that, you need to do something with your storage, which might not be hyper-converged, but maybe something different. And yeah, automation is really the key aspect here, because this will give you the flexibility. Once you've defined certain templates for your network, if you wish, or the environment, you can just go and repeat that. And if you've thoroughly tested all that, you can easily repeat multiple times without applying any errors. Because if you do that by hand, you will apply probably more errors than if you automate that. So you'd probably start with a POC. And you want to get rid of something like this. So, you know, the process of designing, testing, and all that, with the NSX and the whole SDDC, you can really speed up those things. You won't get rid of these steps, because if you really want to get the most out of this, you still need to do design. Basically, before the design, you need to analyze things. Because when you start building software-defined or cloud-based, you really have to ask sometimes yourself, is the way how I'm doing things right now really the best way? Maybe there are other ways, and you can do differently things with the NSX. And that's why I say, and I'll repeat a couple of times, you need to know the tools and its capabilities and then start using it. Because we've all seen this. As I've said, I still do some support. I started as a support engineer, and usually it was something like that, right? You don't have enough sleep, you ran out of weekends, you become impatient because there are a lot of things you have to troubleshoot and all that. And you can ease those things with the NSX. A typical existing environment will be comprised of all those components. So network, but network is not the only thing. As you've seen, the NSX is basically a virtual layer. It's a software-based network. It needs some hardware resources, so it has to run somewhere. So don't forget about compute. The CPU, the memory, and storage at the end of the day, because your virtual router, distributed logical router, has to be somewhere. It needs the resources, it needs the storage to be somewhere. So you have to take into account all these components, when you do the SDDC and of course also the NSX. The design, again, I'll emphasize a couple of times. Design is really, really important when you do this. Some of the things that you might be doing currently in the network are not the best thing or the best ways how you should do things. Probably a lot of people here would raise hand if I ask you, do you have layer 2 domains that spread across the whole data center? It's the way how we've done the network for the last 20 years because of the spanning tree, the VLANs, the trunks, and all that comes with that. Spanning tree and all that, the VLANs, trunks, they were built or people came up with those solutions 20 years or more ago, so they were not built for this flexible changing environments. So you need to redefine or rethink how you do things. Mimic the service providers. NSX in its essence, because it's an SDN solution, uses the VXLAN overlays, standard base encapsulation with VXLANs, which it takes the traffic, encapsulates, and then it can be forwarded through the layer 3 routed network, which could be in your data center, or basically I should say should be in your data center, so you don't get any of the problems of spanning tree, underutilized links, broadcast storms that hit your core network infrastructure and take down your network infrastructure. So NSX enables you that because it uses the VXLAN overlays. That's key. Why don't do things like the service providers do? Because they've been doing that for a long time. It's very similar to MPLS and MPLS VPNs. You have a core network infrastructure, your physical stuff, which just needs to take care of transferring the packets through the network, and that's it. You don't want your core network infrastructure to be hit by any illnesses or whatever that's on the edge. That's why VXLAN overlays and NSX does that. Takes it, encapsulates to the other side. I only need to know the VTAP, which is the endpoint where my destination is. So use it, why not? So that's what NSX enables. Layer 2, you could still spread. Let's say layer 2 is really, really something that we've been trying to get rid of for, 15 years, but still no, let's say, real result. There might be applications that need layer 2 for, let's say, because they are badly written, some kind of clustering solutions, whatever. With the NSX, that's not a problem. Again, as I've said, it encapsulates the traffic. So basically on a virtual layer from a virtual machines, the two instances of the application that might need layer 2, they're going to be like on the layer 2 segment, like on the same VLAN in the same IP subnet, whereas when the traffic goes into the physical network, it's basically encapsulated in the VTAP, in the VXLAN, it's sent to the destination VTAP. So your physical network doesn't have to know about that, which also simplifies the way how you deploy the physical network because, currently with the virtual environments, you need to deploy all the VLANs, which translate into the port groups on your physical network. Take them through the trunks, define on all the switches, regardless of which switches are, but you have to do that through all the network. With the VXLAN overlays, you only have to carry across a couple of VLANs, like management, vMotion maybe, iSCSI or NFS if you're using Ethernet-based or connected storage, if you're not using the fiber channel. But that would be all, and maybe those VLANs that connect your virtual world to the physical world. So you really minimize things, and you could actually minimize even that if you'd wish. But point being, once you deploy the NSX, deploying a new segment doesn't mean that you have to do something on the physical network. It really simplifies also the physical network. Of course, there are certain things you have to properly also design a physical network and implement it to get all the benefits out of the NSX. So as I said, don't forget about all those components. They're really, really important because otherwise, again, waking up before 7 a.m. really should be illegal. So when you do the redesign of the network, your environment, again, NSX being the crucial part of virtual infrastructure or virtual network layer, you'll have to think also about other components, as I've said. The NSX, the virtual network layer, will give you the benefits of speeding the deployment of new segments, let's say. New applications. Somebody comes up with a bright idea, I need a new segment for this application, and I'll have one instance here, one instance there. And normally what you do, you'd have to deploy the VLAN here and all the switches, all the trunks, make sure that you really did that properly. Maybe use some management tool, but you never can be really sure for that. But in this case, you only need to define a thing called logical switch, which is a layer 2, let's say, segment, and you apply the IP address, which would be the gateway. You don't think, one of the things which is simplified with the NSX is also the deployment of the default gateway. How many of you have had to dealt with things like VRP, HSRP, GLBP, and stuff like that? In the physical world, you need to do something if you want to have the redundancy for default gateway, right? You need a protocol because your switches, routers, whatever, firewalls, they need to share that default gateway IP address, the virtual IP address, which is applied to your servers or your users, the desktops or whatever. Because if one hardware device fails, it has to fail over to the second. With here, you just need to define the gateway on the, let's say, NSX level, apply it, and it's distributed across the hosts. So every host does the routing, so you don't have to go outside if you're within the virtual world. So again, other things really that you need to keep in mind, and we'll see why. So the goal typically is, and it's a bold statement, typically is you want to get something that is, and I'm going to read because it's a long statement, flexible infrastructure not limited with hardware, focus on allowing the applications to run and in such a way that SLA is met. So basically that your users are happy. Really, really bold statement. This typically means you need to do a lot of things. NSX being part of that, important, but things that really give you the flexible infrastructure is, thing called stateless configuration. What does that mean? What does that mean? That means that if my server fails, I really don't care. I bring a new one, put it in, which means I have to be able to administratively define things like MAC addresses, management addresses, worldwide names if I'm using the fiber channel, UUIDs, firmware if I wish. I don't want to deal with that. That gives me stateless server, and of course I'm booting the server off the storage, not local storage, because if server fails, I just need to replace it. Statelessness also means I don't want to think about when I replace a physical device like a switch that I need to load all those VLANs, trunks, and all that stuff. I just need to replace the physical switch with a minimum config, maybe use some automation so that it's auto-configured, brought up, but then I have the virtual infrastructure, the network, already configured on the NSX layer. There are other things that gives you the flexibility. The multi-tenancy. Nobody typically, when I say multi-tenancy or when people typically talk about multi-tenancy, they think about service providers and customers. But with this approach, you can actually redefine how you think about the multi-tenancy. It's not only the customers. Why don't you think about a multi-tenancy like I have a test environment, I have a development environment, I have a production environment. Those could be 3 different tenants. Why not on the fly create a test environment from my production environment? Also for the network part, you can do that here because I can really do and just use the same IP addresses. I could have an overlapping IP addresses, do testing that I need to do, upgrades or whatever, and then decommission thing. I don't need to have additional set of network devices, physical to test, dev, or whatever. So tenant is really flexible term or means many things to different people. Automation, seamless upgrades, all that stuff. How do you achieve that? Well, applying the virtualization to different parts, so also the network. And I'm going to get back to the commodity hardware at the end of the presentation. A lot has been written about that on the internet, saying that, yeah, you just take something off the shelf, put it in, and start deploying the software because it's software defined. The truth is somewhere in between, and I'll share the experience with you. You want to achieve this goal also by deploying topologies for the network on the fly. Again, as I've said, I don't want to have my test environment up and running all the time. Maybe I don't need it. Why would I spend the resources for that? I can spin it up 15 minutes. That's really doable. And I can have the complete replica. Again, don't forget about the compute and the storage. I have to have also those parts that take care of compute, store it so that I can really spin things up. But if I have everything in that manner, I can really do that in 15 minutes, and I have a test environment. I can test the upgrade process, and then I can just decommission. Or maybe I promote my test to a new production and demote current production to a old environment or test environment. So usually this is how it begins. Redesigning the network, logical network, step number 1 with the NSX. You start with a POC. You look at your network and you say, okay, because this is the way how I can do things. There are a couple of things which have to be deployed there. There are components. I won't go into all the details. You can reach me later if you wish, because we don't have enough time. But still, there is a thing called the ESG, which is basically a virtual machine, a gateway, which provides you connectivity from virtual world to the physical world, because you still need to connect to the physical world. Not everything is going to be virtualized. You could have cases where you have a database server in a physical manner, one instance on a physical server, and the second one in virtual, as a virtual instance, and they need to communicate because they're part of the cluster. Why not? You have your users that are using the desktops, which are physical, so I need to connect my data center, which could be completely virtualized, to my physical users, let's say. So you need that, an edge device. This edge device is not only for allowing connectivity between the virtual and physical world. You can also apply different network functionalities and services there. So like firewalling, that would be more north-south, load balancing, different things. You could terminate VPNs and stuff like that. There's a thing called DLR, which is distributed logical router, a virtual machine that takes care of distributing or doing the routing in the name of your host, because at the end of the day, NSX, it's a network technology, which means you'll have to deal with either layer 2 segments and you'll have to deal with routing. So whoever has the networking knowledge, this is where it comes handy. Your hosts need to know how to reach other networks because, and the DLR is basically the one that takes care of that. And also the internal east-west security policies, you'd need it for that. So when you deploy the NSX, there are a couple of phases you would do. The first phase is there's the infrastructure part of the NSX that you need to deploy, which is basically I need to create my vehicle, let's say. I need my steering wheel, I need my wheels that will drive me somewhere. So there are components like the distributed switch, the manager, the controllers, VXLAN pools, the ESGs and all that. This is what is the thing that I need to prepare my environment so that to be able to deploy it. Second phase is when things get more, let's say, interesting, because this is when you would start moving your workloads to the NSX. So you would deploy the virtual networking, basically define the virtual layer 2 segments, apply the IP addresses, and start moving things into the NSX. And it's basically just applying proper port groups to the virtual machines, nothing more than that. And yeah, okay, maybe if you start deploying the security policies for east-west in a distributed manner, you could do it also there. The third phase is ongoing changes. This is something that you always need to do because there's going to be someone coming, I need a new segment. So you need to deploy a new logical switch, let's say. Now, when you do this, so we've been at step 1, single tenant, you might reach a phase where you see, okay, maybe this is not the best way how I deploy the NSX. And the NSX enables you to do different things. You don't have to follow the old way. So thing is, maybe this is the time to do the redesign, which means that, okay, this might not be the best way because I have a single device that provides me physical to virtual connectivity. Maybe I'll start, doing tenants. As I've said, test dev prod environments. Why not? So I can do that. I can do, because there are some drawbacks of the single tenant, and I can redesign that. And I can end up with something like this. I have an ESG per tenant. Let's say I start with development, test, and production, and I have a DLR per tenant. What does that mean? It means that I just create new virtual machines which take care of the networking, the virtual networking. And one more important thing, to get from here to here takes me maybe half an hour, because you just redeploy things. Okay, you have to sit down, think it over, but once you've done to deploy, I'm deploying 2 additional routers. but it's half an hour and I'm done. I deployed new a DLR, again, a virtual router. I deployed new ESG, which might be also a firewall, half an hour and I'm done. And I can start scaling. Of course, that has some implications on the compute and the storage. You need more CPU there, maybe you need more memory. So there are always trades off, but you have to do that. And I could end up with something like that. If I start thinking about my applications as a tenant, and I get more flexible environment, I could deploy multiple tenants. I could bring my applications in a more smaller, let's say, I shouldn't call that container, but for the purpose of the presentation, and I can have multiple tenants. I can start deploying an e-commerce and dev for e-commerce, test, and production. I can create those things on the fly. That's important. Half an hour, and I have a test environment from production for the e-commerce, and I can then decommission it on the fly. That's the flexibility, and that's the power of the software-defined networking, which NSX is. And again, as I've said, automate with a PowerShell. So it's very easy to change the way how we've done the networking for the past, 20 years, because I can do redesign, redeploy, redesign, redeploy. As I've said, maybe half an hour to completely change the network. What's more important than that even is that I don't need the downtime. There will be least downtime because, okay, if I redeploy a router that's currently used, if I enlarge it because I need more throughput, there would be some fluctuation, but it's not like I have 15 hours of downtime or something like that. Of course, if I don't hit some kind of a bug, but still. So it's easy to go through this process, and I can constantly improve my network or change my network to the needs of the applications, easily to change. So the important thing when you do the NSX, the virtual network, is to admit or take into account that your physical network also matters. This is the way how it usually begins. Step one, let's use the existing network. Existing networks are not built for, let's say, not to say for the NSX, but for the way how the things communicate these days in virtualized environments where we need flexibility and all that. Because you have either full mesh or partial mesh in the network. You have links, that and that. You have spanning tree. You have problems in your physical network. And if you put just NSX on top of that, you will sooner or later face some problems because your physical network won't handle that. So the second step is usually let's redefine also the physical network. So let's come with something like what's called leaf and spine topology, because that gives you the predictable latency between the endpoints that are connected to the network without having to think how the traffic flows through the network. Because a single packet could go multiple times through the network because I'm virtualizing things, and I don't care. The prereq of doing software-defined networking is also that my network should give me seamless, high availability. I need whatever bandwidth I can get, and I don't care about that. So that's something that the physical network has to fit, and that's why most of, let's say, existing, they don't really fit that. Why? Because they're also built on spanning tree, VLANs, trunks, and all that. So usually, the second thing is let's do and redesign the physical network, because this is where you have to deal with things, how I'm going to connect and integrate the virtual network with the physical, because I still need, as I've said, connectivity to my physically attached or physical clients, users, maybe databases. Why there are network routers, firewalls, whatever, but those are physical devices. They won't go away. They are there. I need to be able to integrate. So I need different types of connectivity from the physical network perspective towards the NSX also. Layer 2, and okay, layer 2 within the NSX will be VM to VM, VM to physical firewall, because you might have still physical firewall taking care of security in the data center. Physical server to physical server, and so on and so on. Layer 3 with default gateway, so I don't care, but I still need that one. I don't care on the level on the physical network, but I still need to be able to manage that. And layer 3 with dynamic routing, so your virtual tenant, which is bounded by the ESG, has some networks there. My physical network has to be aware of that because my user is accessing the database which is running as a virtual machine. So I need to tell my physical network how to get there. That's routing. You cannot get rid of the routing. Do's, don'ts, recommendations, and designs. As I said, when you do the NSX, when you design and all that, you will go typically through something like this kind of process. This will get you the most benefits, the best result deploying and using the NSX. Let's say micro-segmentation, because you can do rapid on-the-fly curate decommission of the environments, of the tenants, whatever you do that. As I've said, 15 minutes and you're up and running with complete replica of the production environment. And one of the things which this enables you is bundling, let's call the application at the end of the day, it's not only a VM. It's a VM or set of VMs. It's also a set of firewall rules. It's maybe a set of load balancing rules. It's also a set of IP segments. So if you look at that way, if I bundle that, I could easily move my application, which is a small, let's say, container of all these things, and I could migrate the workload easily between the data centers. Now, doing hot migration to public cloud, that's a unicorn. That's something that's not really achievable because you have to transfer data there. In public cloud, it means you typically have to transfer a lot of data, so it's more likely that you will do cold migrations. So NSX design, these are the aspects I need to think of. This is the part of the infrastructure that drives my virtual network. This is the part which is actually interesting from my workloads perspective. I deal with the layer 2 segments, which are basically the VXLANs, the subnets. I have to think about the routing to the external world and also internal routing. Connectivity design, high availability, I have to think about that. My virtual network is running on top of the compute, so I have certain ways of how I can attach that so that I don't get into a situation where things fall apart. Because, you know, a chicken and egg problem. If I put everything on something, so even my brains or my driver on the infrastructure, what happens if the infrastructure, there is a problem, and where's my driver? So I have to properly design the NSX to make it highly available. I mean, my infrastructure, the physical. The design for the tenant, my way out to the physical world, my ESG, this could be layer 2 or layer 3 connectivity. Layer 2 if I have something that's on the same subnet here and here. Layer 3 for everything else. Rule of thumb, use layer 3. Layer 2 is bad. Layer 2 always gives you problems. You get split brain problems and stuff like that. Logical switches and my distributed logical router, which is representing me basically my hosts. So this is VXLAN based overlay networking. This is, let's say, could be VLAN based trunking like we've used to. Routing design, we do the routing. NSX is virtual networking solution. I have to deal with the routing. So I have the knowledge of routing, no problem, but I have to deal with that because I will have typically even more networks than in my physical environment because NSX enables me that. So I need to be able to tell what these networks here are to everybody else. So I'll need to do something, maybe OSPF. I need to do OSPF design, for example. Not necessarily I could do with static routes. Physical network design, as I said, it's really important, so I need to design my leaf and spine fabric because step 1, using just existing network probably won't cut the mustard. And then there are other things like connectivity requirements within the data center, connectivity requirements between the data centers. Point being, okay, yeah, I might have the applications that span between the data centers so that are so bad that I need to have layer 2 in between. NSX enables me that because I can actually just, stretch the VXLAN. Still, from the perspective of the application, that's not really what I should do between the data centers because the end of the day, if I get a fiber cut between the two data centers, I will still have split brain problem with two same subnet being at two data centers. So which one do I trust? How should my network respond? Or I should come up with something to really do that. I mentioned the compute, so I have to think about my physical server infrastructure because this is where my NSX is running. There is a part of the compute which is where my workloads, VMs, the applications are. There's the part of the compute where my infrastructure needs to be hosted. I shouldn't mix those two because I'll get into problems. And of course, also the virtual infrastructure, your clusters. You know, putting everything on a single cluster because you can do it doesn't mean that you should do it. So things that you can doesn't necessarily mean that you should. Last but not least, the storage. Because if you want to spin up a production test environment like in 15 minutes, really part which is really, really important because you're going to be, or the system's going to be cloning the VMs, is a storage that can handle the load. A storage that needs to handle load. These days, it's basically flash-based storage. This just doesn't cut the mustard. Last, not least, about the design is think about dependencies. I mentioned them a couple of times. As I've said, it's a solution. You have the infrastructure part. I shouldn't put the infrastructure part on the same part where my user or applications are, because I will have user traffic, I'll have infrastructure traffic, and I need some resources to really ensure that my virtual router providing me physical to virtual connectivity has enough resources and enough connectivity, and that it can run so that some application running, that there's not some VM running the application on the same host taking all of the resources. Recommended practice, have a separate clusters. Stretch clusters, as I've said, though, it's really not something you should use, but if you have to because of certain requirement, yeah, you can do it. So the infrastructure in the NSX, the parts which are important for the whole, let's say, environment to run, there's a manager, there are controllers, there are EAGs and DLRs that you would define. As I've said, you would typically put this on, this on the management or management edge cluster, and maybe have a separate edge cluster for the EAGs and DLRs, because this guys providing connectivity between the virtual and physical world, they need enough CPU resources and memory. They shouldn't be, they should have enough of those resources. Putting it all together, you do a lot of things. It's out of the box, it's a lot of automation, but it makes sense to automate some other things sometimes. So this is kind of a chart that tells you where or when you should start automating. There are two options. First of all, for the migration, scripting gets you the most flexibility, which means from the current environment to the NSX goes with scripts, PowerShell, Python, Ansible if you wish. I can collect what's there and I can throw it at the NSX, create the logical switches, DLRs, EAGs, whatever. And then I move my workloads. Further on, when everything is up and running, I need some kind of orchestration system because maybe I want to give my users, let's say those that are educated, ability to deploy a new environment or clone it based on some templates. So you'll probably have both of the options. Tenant deployment process, there are a lot of things that you will do. So this doesn't only apply to the NSX, but it's the whole SDDC part. Compute storage, physical networks, virtual environment, and there is going to be a virtual network that you need to do certain things. So there are a lot of things you need to do, and it makes sense to automate those things, because once you've defined the process, it's the easiest way to replicate the process is just by having either scripts or the automation orchestration system, because you just do it, and you won't get into so many problems because you won't do so many errors, because once you've defined and tested, validated, you won't have problems. So that's, at the end, you could end up with something like this, having multiple tenants connected in certain ways, having routing and all that. Deployment to-do list. Why am I emphasizing the automation? Because you have to do a lot of things. For the NSX itself, logical switches, DLRs, ESGs, routing, virtual to physical connectivity, all these things need to be deployed and configured. You can click through or you can automate. And of course, there's a storage in vSphere that takes its toll. There's a physical network, there's a physical server infrastructure, all that you can automate. In summary, I hope I didn't scare somebody off. The NSX gives you a lot of flexibility. It's a tool, as I've said, that gives you an option to really redefine how you do the networking stuff in your data center, connect data center, move your workloads and all that. But if you don't know the tool and if you're not applying it in a proper way and if you forget about certain aspects of the infrastructure, you might not get the best results. So sometimes we're trying to solve the scaling issues, which are not really a scaling issues. That's what this slide is trying to tell you. And sometimes we might get overloaded with the information either from the internet or from some presentation telling you you can do this that way, not telling you that you should think about those other aspects, which I've tried to, let's say, emphasize. So at the end of the day, commodity hardware, it might be good, but honestly, from the experience, usually might give you a lot of problems. The thing is, whenever you start virtualizing things, your device drivers are becoming really important, the firmware for the devices, like in this case, the network. So if it's not really thoroughly tested, you might get into problems. Your environment might fall apart. So point being, and from experience, commodity, white box, whatever you call it, infrastructure, the compute, it typically would give you more problems than maybe benefits. So either you have enough money and people to test everything like the do-it-yourself guys do, the AWS, Google, Azure, or you do smaller size POC, design and deploy, and then really follow the hardware compatibility list to use things that are really proven and tested. What's also true for any of these solutions is if you look, you can save money, let's say, with solutions like that, but it's not like that I'm going to pay less for this compared to that. It's just not like that. Things where you will save the money is that you're going to be able to spin up a test environment in 15 minutes. What does that mean compared to maybe 2 days to have a test environment to test the upgrade of your ERP system? That's where the money savings come from. Not from buying solution, but also redefining the processes, how you do stuff, optimizing those things, spending less time for repetitive tasks, having less options to implement an error. That's where the savings come from, because trying to get something like fast, cheap, and great is like chasing the unicorns. There's just not such a thing. The analysis, look at the way how things are now used. The applications you need to understand what and how they are used, how the users are using them, and then translate that into a solution based, let's say, on the VMware NSX. Don't try to feed the tool, but use the tool to address those challenges. As I've said, this is my contact information. You can get me on the email. You can get me on LinkedIn, Facebook. Hopefully I've given you enough information, useful, and if you have any questions now or later, feel free to ask or contact me over the email. So thank you.